Basically, this is SIT. It's a survey and inspection device. What it actually is an unmanned rail vehicle. Basically, it operates more or less like a drone. What it does is it actually removes obstacles that are on the rail. At the same time, it actually tests the profile of the rail as well as the gauge of the actual rail, and it also got the capability as well to test the voltages of the rail. This is done just to reduce the likelihood that there can be any derailments. So basically on the actual rail itself, if ever there is a damage on the track, provided there is a chip, it is able through these laser sensors just to be able to detect those chips there. Then it actually gives a profile of it in real time. Basically, there is some cameras in front there that actually gives also a real-time view basically of what it sees. Also, the numbers that it actually gets, whether it's voltages or also the number of millimeters or micrometers of the readings that it's actually getting on the track, it's able to actually profile it on the screen. Then it can be seen on the command and control center basically. So if ever maybe an obstacle is actually found on the rail, what it basically does actually sends a signal back to the driver as well as to the command and control center basically there. So it will help the driver to actually make a decision whether to stop immediately or to actually reduce speed basically. So basically that's what it does. It also got the ability as well to be able to remove the actual obstacle, provided it's actually a lightweight obstacle. Because the real size of the seat basically is about 450 kgs. So it's able to move stuff that is plus minus 100 kilograms. It can actually move it off the track, depending on how it is, whether it's actually the size of a rock or maybe it's a dead boat that is on the track. It can actually make a decision there. So there is an option to actually manually override, manually override and actually make a decision from the control and command center, or what it can actually be done is just to push the obstacle on the side of the track as well. So basically on its own, the way it actually operates on autopilot, more or less like it's an autonomous rail vehicle. It can actually work on its own without any interruptions, but now there is an option for it to be switched as well to manual. So when we switch on to manual there, probably just to make a decision about maybe a rock or a landslide that has happened or a mudslide, then we can switch back also onto autopilot once that decision has been made, maybe that obstacle has been cleared. So we can actually do it that way. So the main advantage that why CSIR worked with Transnet in order to be able to develop such a product was because there's also a need for that in Africa as well. Because we actually test the profile of the rails once per month, once per year, just the continuity, just to see whether there's some threats or some dangers, or maybe there is some loose cables there. It's actually done once per year. So we're actually doing it for countries like Zimbabwe at the moment. We're looking forward to moving over to the rest of Africa as well, just to be able to do that. We will be doing that probably once per month or once per week, as opposed to doing it once every year. So at least that would be an advantage as well.